Hello, Twitch and YouTube. I think I'll have to check if this is set up correctly on YouTube. I don't think. Let me get some settings here. Okay, I was just getting some things set up. Pardon when I'm a little more sniffly than usual. Have had a cold recently. Is the video working? Yes, it appears to be. Okay, so I got interested in learning Unity recently, so I downloaded it and some tutorials. I've gone through this one a little bit. It's just learning to navigate, basically. I defined these numbers around the playground. And I got through that portion, so let's see what's next. I found all the numbers in there. And I must hydrate. Okay, finish that one. Pass the scene view flying test. Fly through rings around the playground. Okay, let's do that next. Okay. Activate the flying course, huh? In the hierarchy window, select the rings game object. Got it. With it selected, look at the top of the inspector and locate the checkbox next to the title Rings, then enable it. Ooh. Oh, okay, there we go. Double click on it in the hierarchy window. Okie doke. Go to rings 1. Center on that one. Okie dokie. Hold Alt and left click to orbit around it so you're facing the next ring and the arrow is pointing away from you. There we go. Got all that. First, you'll go through the rings using the trusty technique that will serve you well through your Unity career, frame orbit zoom. This technique allows you to quickly focus on any game object from any angle you want. Technique. Technique. Zoom through the center of the ring using the scroll wheel or trackpad. Okie dokie. Once you're through the first ring, continue through the obstacle course. Select the next ring, then press F to frame it. It's taking a minute. There we go. Frame, orbit, and zoom. Then repeat. It expects it to take a while, but I've played enough games. This is pretty easy. I think so, anyway. What did I actually do? Ah? The hell am I doing? Okay, maybe I did something wrong. I thought it was easy. I think I did something wrong. I thought I'd selected it just by clicking on it here, but I don't think it did that. Okay, select the next one. F. Okay, there we go. No, this is easy. Oh wait, I did it wrong. Well, this whole thing is to learn. Orbit behind, zoom through, then repeat. Okay, now we've got it here. We're zooming around through these rings around the playground now. To the fourth one. Frame it. Zoom behind it. Scroll through. Next one. Nope. Frame. Whoop. Through the ring. Frame. Rotate. Zoom. Frame. Rotate. Zoom. Okay, I went through all those rings. I'm a pro now. Next, you'll test your fly-through mode skills to go through the course again. You can actually get anywhere you want in a scene using fly-through mode. With more practice, you'll eventually settle into your own 3D navigation style, likely using a combination of fly-through mode and frame orbit zoom. Right-click and use the WASD keys. In fly-through mode, you can also press Q to go straight down and D to go straight up, but you should probably master using the WASD keys first before trying to integrate those keys. Okay, right-click and use WASD. Wee. 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 Woo. Wee. Okay. Next. Now deactivate the rings to hide them. Goodbye, rings. We have flown through all of you. Proceed to the next tutorial. Okay. Yes, I want to save. Create a mural in the scene view. Now you're much more comfortable navigating the scene view and maneuvering through 3D space. The next critical skill to acquiring Unity is the ability to move and position objects within this space. In this tutorial, you'll utilize the Move and Rotate tools to craft a mural of your own design using the colorful pieces of the classic Tangram puzzle. First, you'll want to get into an optimal vantage point to view and arrange your mural from directly above, looking down. We've also provided you with a reference image of potential design options for your mural, which will be helpful to have in view as well. You can choose to follow along with the turtle mural example in this tutorial, select another possible design from the reference image, or design your own unique mural. Select the mural game object. Enable the checkbox. Double-click it. Get an optimal top-down view. Oh, there we go. Okie dokie. The Move tool allows you to drag objects around the environment using the 3-directional axes arrows. The Move tool also gives you the option to use either global or local coordinates. Global coordinates are kind of like north, south, east, and west, which are constant. Local coordinates are more like left and right, which change depending on which way you're facing. Select the Move tool. Pardon the sniffles. At the top of the scene view, open the Coordinate System Selection drop-down menu and select Local. The top of the scene view, Coordinate System Selection. Where is that at? I'm not getting where that is. Yep. How do you make the video bigger? Can't see what they're doing. Coordinate System Selection. I'm not seeing that. It says there's a drop-down menu. I'll just skip it. Move the first large piece. Select the big red triangle. Click and drag it to the center of the playground. That is not the triangle. Undo, undo. I was moving the whole ground instead of the triangle. Just select it from over here. Sheesh. I moved the triangle instead of the entire ground. Rotate tool. Wee. Wee. Move the next piece with shortcuts. Shortcuts Q, W, E, R, T, and Y allow you to swiftly flip through various tools, with W for the Move tool and E for the Rotate tool. QWERTY. Oh, how handy. Okay. Switch to Move. Select your next large triangular piece. Ooh. And change to Rotate. I'm not really doing any particular design, I'm just moving them around. Remember, don't drag your mouse in circles like a wheel. Click and then drag in a straight line. Ah, now I get it. Yeah, I was trying to do it like a wheel before, and that's why it wasn't working how I thought. Ooh. Now I get it. I didn't really pick a design. I'm just moving pieces. For the next piece, you'll optimize your workflow even more. First, you'll shift to isometric mode to eliminate perspective distortion, allowing you to focus solely on moving objects along the horizontal and vertical planes. Then, you'll use the technique of moving an object along two axes simultaneously. This will be much more efficient than the earlier method of moving an object along one axis at a time. Select the next puzzle piece with the Move tool active. Right-click the Scene View gizmo and disable Perspective. This will switch your view to isometric mode. Get the small purple square selected. You can now move the piece freely along these two axes, just as you would slide a puzzle piece across a table. Position it where you want it. Whee! I don't know. I'm just moving pieces. Complete your mural. I'm not making a picture, I'm just moving pieces around. Whee! Okay, it's totally done. It's abstract. Enable perspective again. Get rid of the reference. Oh. Eh. Okay, there we go. Alt and left click, orbit. See from a more natural perspective. Okay. Save your scene. And next. Proceed. More things to try. Try these optional activities to challenge yourself, build your skills, and improve your project. If you're not interested in doing these, skip to the end of the tutorial to mark it as complete. Rings fly through another mural. Put together the tube slide. It's broken into 3 pieces. Enable it. Focus on it. Oh. We're fixing this slide. It's broken. Now it's stuck in the ground. Whoop, whoop. Wrong button. Ah? Save. Complete the checkpoint. Complete the quiz. There's a quiz. I didn't know there was going to be a test. There's a quiz. Signing in. Complete a quiz to get credit for completing the mission. Which of the following statements are true about the Unity editor windows? Looks like an all of the above. What is the game view window? Which of the following are true about how to navigate in Unity's scene view? What happens when you use the scene view gizmo to disable perspective and enter isometric mode? Which of the following are true about the move and rotate tools in the scene view? Submit answers. I have passed the quiz and leveled up. Congratulations, mission complete. 600 XP. I got 4 out of 5 correct. Okay. Next. Done. Okay, so I'm done with the first group here. On to 3D Essentials. Create a kid's room from scratch, including a bouncing ball that knocks over a tower of building blocks. In this tutorial series, you'll explore Unity's capabilities by designing a kid's bedroom scene with dynamic elements like a bouncing ball and a tower of blocks. You'll learn new skills in 3D navigation, object customization, and using Unity's physics system. You'll also create prefabs, adjust lighting, and capture your scene with a camera. This foundational knowledge is vital to creating any type of Unity project. Open the scene. Project window. Unity Essentials. Scenes. Double click to kids room 3D scene. Let's make that window a little bigger. It's hard to see right now. Oop. Project. Unity Essentials. Oh, I was in prefabs instead of scenes. Unity Essentials. Scenes. Oh, there it is. Double click. Here we go. I don't really see anything, but I did what they told me to do. Okay, I'm not supposed to be seeing anything. Next, you'll add the main structure of the bedroom using a prefab. Prefabs are prefabricated assets that you can reuse across your project. In this project, we provided you with a whole bunch of prefabs that are ready to use as you design this world, including a prefab of the actual room with the walls, floor, and windows. Go to Unity Essentials, Prefabs, Rooms. Click and drag the bedroom prefab onto the center of the ground in the scene view. I didn't see a ground. Oh, there's the ground. I didn't know where the ground was. Oop. Get a good view of the empty room. Am I still in isometric mode or something? Oh, I somehow have a 2D view toggled on. That explains the confusion. I accidentally had it in 2D somehow. That's why it looked all wonky. I didn't know what the hell was going on. I squashed everything. Okay, that explains it. Sheesh. I was really confused for a bit there. I squashed the room into 2D by accident. Now I can see everything. Sheesh. Don't know when I did that by accident. Must have been a while ago, because I was confused why I couldn't move around normally. Okay, now we're in the room, actually in 3D. Position the bedroom at the origin. Pardon the sniffles. Cold. Oh. For consistency and ease of design, you'll position the bedroom at the exact origin or center of the scene using the transform component. Every single object in your scene has a transform component, which allows you to control the object's position, rotation, and scale. The origin of a scene is position 0, 0, 0 on the X, Y, and Z axes. In the hierarchy window, select the bedroom game object. There we go. Go to the inspector window and set the position values to 0, 0, 0. Remember to save your scene regularly. Position 0, 0, 0. There we go. And save. Next, add a bed to the bedroom. You generally need a bed in the bedroom. That's kind of the main point. The main point is kind of having a bed in the bedroom. Kind of what it's for. Next, you'll add a bed against the left wall of the room. The bed will be a central piece of furniture around which other items will be arranged. There are many bed prefabs to choose from, so you'll want to browse the options using the preview window at the bottom of the inspector window before you drag one into your scene. Prefabs, bedroom, there's all the beds. Drag one onto the scene, position it with its back against the left wall. Just single click them to preview. We're previewing all these different beds. Just like a made and a messy version of each. That's cute. I'll do this one. Drag it into there. Against the wall. Rotate it. There we go. There's a bed in the bedroom. Okay. I don't know if that's where they wanted me to put it, but I moved it. Decorate with more furniture. Personalize your bedroom by adding some more furniture. Use your own design sense to arrange items like nightstands, dressers, and chests. Drag furniture items into your scene, then move and rotate them to your liking. I'm so sorry I keep sniffling so much. I should actually take a bit of a break to blow my nose and whatnot, and I'll be right back. Okay, I'm back. I've returned. Take the BRB off. Let the camera back. There we go. Battle. And back into Unity. Leave a corner empty for the block tower, but add some furniture. Dresser. Laundry basket. Nightstand. Rocking horse. Rug. Let's put a big purple rug in there. A nightstand. Somebody's car alarm's going off outside. Nightstand entered into room. Seems a little not rotated quite right. There we go. Oh, there's an alarm clock. I can throw that on top of the nightstand, probably. Yeah, I'll do that. Ooh. Oh, it's way further away than I thought it was. That's why it looked so tiny. An alarm clock on top of the dresser here. Hmm? Throw in a laundry basket. Rocking horse. Cute. Okay. We threw more furniture in there. Hello, TKO. Thank you for stopping by. Proceed to the next tutorial. Oh yes, save the scene. And hydrate. Make a bouncy ball. Create and rename a sphere. The first step in creating a bouncing ball is adding a simple sphere in the scene. Unity provides you with a number of primitive shapes that you can add, including a sphere, a cube, a cylinder, a capsule, and even a flat plane. These simple shapes can be used as building blocks and as placeholders for more complex models. Here you'll create a sphere and rename it ball, which will later bounce off a ramp. In the hierarchy window, right-click in an empty area and select 3D Object, Sphere. 3D Object, Sphere. There it is. Note, when you create the sphere, it may appear in a seemingly random location, which is actually based on the object you last framed in the scene view. You might not even see the sphere after creating it. Don't worry about its location for now. Right-click on the sphere, select Rename, and rename it Ball. Where does it say Rename? Alright. Where'd it go? Sphere. Oh, okay. Rename. Ball. Okay, it's renamed. And save. Edit the sphere's scale. The ball is currently way too big. You need to make it smaller. I was thinking that before they told me. I already know how to scale. I'm just gonna make it a little smaller. Oop. That wasn't what I wanted to. Okay. You can select the chain link icon next to the scale properties to enable or disable constrained proportions. When this is enabled, changing one scale property automatically changes the other two. Yeah, that was what I was wondering why it didn't do. Chain link icon next to the scale properties. Oh, there it is. There we go. That's better. I think I already messed it up a bit earlier, though. Whatever. Might not be a perfect sphere anymore because I forgot to turn that on earlier, but whatever. We're learning. Position the ball in the air. High above the floor near the window. I don't feel like setting the properties. I just moved it by hand. Create and apply a new material. Project window, navigate to Unity Essentials Materials. Right-click inside the Materials folder and select Create Folder and rename it My Materials. Create folder My Materials. Go into that new folder, right-click, create material. Pardon. And rename it Ball Mat, short for ball material. You have just created a new asset in the project window, which means that this material can be used in any scene in your entire project. You've added a new custom asset. You can see from the Create menu when you right-clicked that you can make all kinds of assets, including scripts, animations, fonts, and more. Drag the new ball mat material directly onto the ball, which should make it turn the default plain white material color. I didn't click it right. There we go. And save. Adjust the material properties. You can customize the ball's color and how it interacts with light in the scene. Creating materials can get very complicated, so you'll start by adjusting just 3 key properties. Base map color, the basic color of the object. Metallic map, how metallic the object looks. And smoothness, how smooth the object looks. Selected in the project window. In the inspector window, in the surface inputs section, for the base map property, select the white color swatch and use the color window to choose a new color. It's purple now. Now it's purple. Observe how your changes affect the ball's appearance. Adjust the sliders for the metallic map and smoothness properties to your liking. It's a little too shiny. I just wanted to see what would happen. And that's completely matte, so that's weird. I want it a little shiny. But we don't want it to look chrome. That's weird. It's supposed to be bouncy. Okay. Next. Add a rigid body and test. Now that your ball looks ready for action, it's time to bring it to life by simulating physics. To give the ball physical properties, you'll add a rigid body component to it. Without a rigid body component, the ball will stay at its current location in midair. But with a rigid body component, it will have mass in response to gravity. I don't need to enter play mode to know it's just going to float there. Select it in the hierarchy or scene view. Add rigid body. Hold on, where? Oh, add component at the bottom of the inspector window. There we go. And rigid body. Where? Ooh. Add component. Oh, in the search bar. Okay. There we go. Enter play mode again and watch as it responds to gravity and falls to the ground. Then exit play mode. Ooh, not save as, just save. We've added gravity. There it goes. It fell. Okay, we can exit play mode now. Save. Create and apply a physics material. Your bouncy ball's bounce is probably pretty disappointing. It behaves more like a bag of sand than a lively bouncy ball. To make it bounce, you'll create and apply a physics material. Unlike standard materials, which control the visual aspects of game objects, physics materials govern the physical behavior of game objects, like how they bounce upon impact. Right-click inside the My Materials folder and select Create Physics Material. Rename the new material ball Physics. Create Physics Material. Ball Physics. In the inspector window, set the bounciness property of this physics material to 1 for maximum bounce effect. Bounciness property 1. Pardon the dogs. Bounciness 1 for maximum bounce. Drag and drop the physics material onto the ball in the scene view. No, I'm not paying for viewers. Fuck off. To observe the changes, select the play button and watch as it bounces. Bend, 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 bend. Bend, 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 bend. Spammers are bent. Please excuse the dogs. How dare neighbors exist? And band. Enter play mode. Watch as the ball bounces. Arf, bark, woof. How dare people walk outside? The ball's bouncing. Isn't that amazing? It bounced like once or twice. Amazing. Okay, save. Next. You'll have customized this ball a lot at this point. In this step, let's take a moment to review all of the components that contribute to the ball's behavior and appearance in Unity. Examine it in the inspector window after selecting it, in the hierarchy window. Locate the transform component. It sets the position, rotation, and scale of the ball. This is the only component that is required for every game object. Locate the mesh filter component. It determines the shape of your game object. A mesh is a wireframe 3D model. In the case of the ball, the mesh is set to a sphere shape. Locate the mesh renderer component. The mesh renderer component controls the external appearance of the ball. Try to find the material you apply to the ball. When you apply a material, it shows up in this component. Locate the sphere collider component. The sphere collider component defines the physical boundaries of game objects for collision purposes. Try to find the physics material you created and applied. There it is. Locate the rigid body component. Oh, there's the physics material. There's the rigid body component. The rigid body component integrates the ball into Unity's physics system, giving it properties like mass and drag. Add a ramp and test collision. In this step, you'll add a ramp that the ball can bounce off. The ramp has to be positioned precisely beneath the ball, which can be tricky if you're viewing the scene from an angle. You'll see how to use framing to help with this. Navigate to prefabs, shapes. Yeah. Drag the ramp to approximately beneath the ball. Nope, wrong way. Roots to the top view. Eh? Something went wonky. I don't know what happened. Okay, I think I'm still streaming. I'm not sure what happened for a second. Move it to the top of the ramp. Enter play mode. See what happens. Okay. Wait, it's supposed to have passed through the ramp? I don't think I was looking close enough. I'm looking closely this time. I didn't really catch that, but I'll believe them. Add a collider to the ramp. Please excuse the dogs freaking out. I keep thinking the ball is somewhere way different based on where its shadow is. There we go. We need to add colliders so stuff won't just pass right through the ramp. You'll now fix the ramp by adding a collider component, which is essential for physical interactions in Unity. A collider is a component that defines the shape of an object for the purpose of physical collisions and interactions within the environment. Without a collider, an object has no physical boundaries, and other objects can go right through it, like a cloud. The sphere primitive you added earlier for the ball already came with a sphere collider. That's where the physics material is attached to. Unity provides various collider shapes, such as sphere, cube, and capsule colliders. However, since the ramp has an irregular shape, you'll use something called a mesh collider, which conforms to the unique shape of the object's mesh 3D shape. Select the ramp. In the inspector window, select Add Component and search for Mesh Collider. Mesh Collider. Add it to the ramp. Enable, in the Mesh Collider component, enable the convex property. Enabling the convex property simplifies the collider into a convex shape, almost as if you were wrapping the object in some hard material. Unity needs mesh colliders to be set as convex to allow them to interact with other objects. Enter play mode, test the ball's interaction with the ramp. Okay. Save. Oop, I didn't exit. And done. Make a tower of prefab blocks is next. The bouncy ball will be able to knock them over. Adds in about 3 minutes. Alright, I was marking some stuff complete on the Unity Pathway Online. No, actually, I think that's for when I've completed all the steps. Okay, never mind. That's later. You're about to begin the construction of your block tower. To make your first building block, you'll start by adding a primitive cube. You'll add it to the scene, rename it, then reset its position to the origin as a starting point. However, this time you'll use a new technique for creating the new 3D object, and a new technique for resetting the object's position. Top of the hierarchy window, select the Add button. To access the Create menu, then 3D Object Create. Wait, what? Add button. Oh, 3D Object Cube. A cube. Rename it Block. It is Block now. In the Inspector window, select the More menu. In the upper right corner of the Transform component, transform. In the Inspector window, select More in the upper right corner of the Transform component. What? Where? Transform. Where does it say More? Eh? That wasn't what I wanted. Eh. Block. don't know what I did by accident. I somehow made inspectors show up in a separate thing. That works though, I guess. Sheesh. Inspector window. Oh, they mean the 3 little dots. Okay. That's what I thought. I was confused. Select reset. Okay. To reset the cube's transform properties, including resetting its position to the origin. This should position it in the center of the room, halfway sunk into the floor. Yep. Reposition and scale the block. Select the block. Reposition it above the floor. Oh, there it is. Just looking at the ramp instead of the block. Scale. So it's a tall, skinny block that the ball can knock over. Scale. Move. Okay. Frame it. Move the block above it. Whoop. Center the block again. Get a better view of it. It's telling me to go into play mode, but saying the block won't be able to be knocked over yet. I didn't. It's not below it properly. That looks better. Okay. Okay, next. Add a rigid body component to the block. With the block selected, select Add Component in the bottom of the inspector window. And add rigid body. Enter play mode. The block should now get knocked over. It didn't knock it over. What did I do wrong? I thought I just added rigid body to it. Block. Inspector. I just added rigid body to it. Why did it not work? Why did it not work? I did what they told me to do. I added rigid body to the block. It's saying it's there. It's saying rigid body is there. It's part of the block. Oh, wait. You didn't tell me to add the physics material again, did you? Did I miss that? I feel like you're missing something. You're saying it's supposed to be knocked over, but it didn't. I not? I thought I saw it fall right on it. It's supposed to be able to knock the block over now. It fell right on the block and nothing happened. You told me it's supposed to be able to knock it over. What the hell? Well, I'll have to get back to this part later because I don't know what the hell I did that is not working. Let's just try the next one for now. I don't know what the hell happened. Lights, camera, action. In Unity, the camera game object is similar to a physical camera on a movie set, playing a critical role in how your scene is viewed. When you move the camera, you'll end up with a different view of your scene in play mode. Adjusting the camera's position, rotation, and field of view allows you to frame your scene just as a cinematographer would do so in filmmaking. Select the camera game object. In the toolbar, overlay at the bottom of scene view, enable the camera's option. To get a preview of what the camera can see. Move and rotate the camera, and notice how the camera preview changes. Oh, there it is. Where's the camera preview? I'm not sure I get where the preview is supposed to be. There's lines in front of it, I guess. Yeah, I guess. In the inspector window, in the camera component, use the field of view slider to change how zoomed in the camera is. Field of view. Okay. Oh, okay. So scene view is the whole thing. The game is shown what the camera is actually looking at. Okay, I get it. Kind of sideways. Now it's more sideways. Now it's all kinds of sideways. We're just going all over the place with this camera. Okay, that's much better. Adjust your lighting. So that's the whole scene. That's what the camera sees. Whole scene, camera view. Whole scene, camera view. Whole scene, camera view. Lighting sets the mood and atmosphere of your scene. Unity's default directional light, which acts like the sun in the real world, simulates bright midday sunlight. Please excuse the dogs. Neighbors must be walking theirs. By rotating this light, you can simulate different times of day or specific lighting conditions. In the hierarchy window, select directional light game object. Then frame it. Whoop, what the hell did I do? Directional light. I didn't want to rename it F. I wanted to frame it. Oh, probably because I'm in the game view. That's why it didn't work. There we go. Sheesh. Rotate the light to adjust the shadows and overall lighting. Changes in position won't affect the lighting due to its sun-like nature. It represents a light that's located infinitely far away and emits light in only one direction. In the inspector window, in the emissions section, experiment with color and intensity to find the desired lighting effect for your scene. If you want more of a nighttime light, make the light more blue and decrease intensity, but feel free to keep the sun at a bright midday angle if you want. Color, intensity, shadows. Let's make it more of a softer yellow. We'll try upping and lowering the intensity. About intensity all the way to 1. Now down to 0.5. Oh, actually, let's also get a better look at the difference between yellow and white light. White light, maximum intensity. Yellow light. Blue. Purple. Yellow. Let's do yellow. So I don't like bright white lights. Let's lower the intensity a little more too. About back to 0.5. We'll try rotating that light. It does definitely move where the shadows are. Okay. Edit the skybox. Oop, my phone's almost dead. I'm gonna have to switch to checking on my computer for chat and whatnot. A skybox in Unity is a type of virtual backdrop that surrounds the entire scene, giving the illusion of a distant environment or sky around the environment you create. The skybox contributes a lot to the overall feel of your scene. Unity Essentials, Materials, Skyboxes. Materials, Skyboxes. The current skybox is Sky Bright Cloudy. Browse the other skybox materials and preview them at the bottom of the inspector window. Click and drag any skybox that interests you directly onto the sky in the scene view to see how it looks behind the room until you find one that you like. Previewing the different skies here. Let's try the cloudy one. Drag it directly to the sky. Okay. Save. Incoming ad break in about 4 minutes. Edit play mode tint. By default, the editor windows around the game view become a tiny bit darker when you enter play mode to help visually distinguish between play mode and edit mode. This is known as the play mode tint. In this step, you'll edit the play mode tint to make it more noticeable so that you'll always realize when you're in play mode and avoid losing unsaved changes. Edit preferences, colors, play mode tint. Preferences, colors, play mode tint. Ooh, oh, there we go. Colors, play mode tint. Making it a dark purple. Okay. Should be very noticeable, but still allow you to read text. Oh, I might have made it too dark. Let's see. I made it way too dark. It's definitely noticeable. Too dark, though. Can barely see anything. Where's even the stop button? There we go. Edit. Preferences. Play mode tint. Colors. That is way too dark. Just make it a lighter shade. Let's try that one. There we go. Makes everything a nice pinky purple while I'm in play mode. That block's still not falling over. I don't know what's up with it. Save. Next. Next. More things to try. They're optional. I don't feel like it. Wait, add and frame custom artwork sounds fun. Hierarchy window. 3D object quad to create a flat, one-sided object. Ooh, I'm not in the scene view. Ah. Three D object quad. There it is. Oop. There we go. Position it against the wall, way ahead of you. Find or create an image you want to use for your artwork. To import your chosen image, drag it from your File Explorer into the My Materials folder in the project window. Let's find a picture to throw on the wall. Let's look through my files here. Pick something. A digital art piece of mine of a phoenix. I threw it in there. Okay. Now it's on the wall. That was easy. I think the picture is a little wider than that. But, eh. It's telling you how to make a frame, but I don't feel like it right now. Next. Alright, save. Complete the quiz to get credit. Actually, I think I still had that. Mark is complete. Close enough. I just couldn't figure out why the block physics weren't working. Move on to the quiz. What's a prefab? I'm doing the quiz. What happens when you move and rotate the directional light? Submit answers. Leveled up. 600 XP. 4 out of 5 correct. Continue. Okay. Next. Audio essentials. I need some more water. BRB. We should feed Nugget the dragon. She's hungry. Nugget hungers. It's not loading properly. It's just taking a long time. Well, BRB. Back with some more water. Turn the camera. There it is. Oops, I somehow forgot to take the Cozy Games tag off. This is not a cozy game. Oh well. We don't need the overview. Let's just get to the mission. Open the kitchen scene and enter play mode. Scenes. Open the kitchen scene. Oh, there's the scenes. Didn't see it for a minute. Have to maximize this a little bit more. Kitchen scene. Enter play mode, explore the kitchen scene. I've got pineapple dragon fruit, Mario Galaxy water. It's pretty great, actually. Very pineapple-y, very citrusy. Disney, earthquake. I'm a mature adult. Dizzy. There's an earthquake in this kitchen. I'm gonna throw up. Okay, anyway. Exit scene. Nah. By default, the main camera will have an audio listener component on it, which acts like the player's ears. When the audio listener component is far away from a sound, it should be quieter. When the audio listener component is closer to a sound, it should be louder. With this component, the camera acts both as the player's eyes and ears in the scene. In fact, Unity does not even allow you to have more than one active audio listener component in a scene. With multiple sets of ears in different locations, at what volume would you play a sound? Locate and open the kitchen audio scene. Well, I'm already there. No, I already previewed this as the... I already previewed it before reading everything. Okay, I did that before reading it. In the hierarchy window, select the main camera game object, then locate its audio listener component. Audio listener, I see it. Add a pot to the stove. It comes equipped with a particle system for the steam and for the bubbling, boiling water. Unity Essentials, Prefabs, Kitchen. Prefabs, Kitchen. I'm gonna snack on some pretzel nugs, my most common stream snack, which is why it is the currency. I'm gonna have to either draw or commission a little pretzel nug icon. There's a boiling pot. We're putting it on the stove. There we go. It's boiling. Add component, audio source. Locate the audio resource property. Where's that at? I'm not seeing audio resource. Audio resource property. Where the hell is it doesn't want me to go? Audio resource. It's not there. What the hell? It's like, oh, go to this drag and drop menu. It should be right there, but it's not fucking there. What do they want me to do? Okay, that wasn't how it told me to do it, but that worked. They probably didn't update this tutorial to the most recent version. Enable the loop property. Test it out. Suffer? When did you say that? What? I don't know what that's in reference to. Well, it's boiling. Oh, for what do they expect me to do, I suppose? They expect me to suffer? I guess that's what you're referring to. What do you expect me to do? Suffer? In real life, sounds change in volume in each ear, based on your distance and direction relative to the sound source. By default, audio in a Unity scene is 2D audio, which means that it stays the same regardless of the listener's position or orientation in the game world. 3D audio, on the other hand, is spatialized. The sound changes based on the listener's position and orientation relative to the audio source, mimicking how sound behaves in the real world. Let's make the Boiling Pot audio clip a 3D experience. In the Boiling Pot GameObject's audio source component, which is here, locate the Spatial Blend property. Located here, and drag the slider from 0, fully 2D, to 1, fully 3D. The sound is in 3D. Okay. Enter play mode to test it. And then exit play mode. Whoa, this is boiling in 3D, yo. I'm not sure that's quite accurate. I don't think it would still sound this loud when I'm this far away from the house. This place must be super quiet. I am so long away from that house and I can hear a single boiling pot of water in it. This must be a super quiet neighborhood. What if I get right up in there? It's definitely louder. Oh no, I'm falling in it! It's a horror game now! Ah! Further away. I don't know how I'm walking off of the land. I've flown away from the land, and yet I can still hear a pot of boiling water that far away. I must have superhuman hearing abilities. Hey, what you cooking in here? Bye! Are you making some pasta or soup or something in here? Can I have some? Hey, what you making? Are you making pasta? Are you making soup? I'm hungry. Is there soup? Okay, enough of that. Next. Add background music. The track you select can completely alter the ambiance of the scene. background music isn't produced by anything in the environment. Speak for yourself. I generate my own background music, don't you? And is purely used to enhance the overall atmosphere of the scene. Let's set a mood in this scene with some background music. In the hierarchy window, right-click in the empty space and select Audio Source. Audio Source. I don't know why I said that so dramatically. Audio Source. Rename it Background Music. I'll just say BG Music. Okay. Browse in the project window. Browse the available music options in the Unity Essentials Audio Music folder. You can preview them in the preview panel at the bottom of the inspector window. Unity Essentials Audio Music. Oh, there we go. Here we go. Let us preview them. Let's see what background music we want for our kitchen with the ominously loud pot of boiling water. How do I preview it? Neat. Oh, there we go. Here we go. Classical. Stop it! Oh, okay. Go away. Driving. This kitchen is suddenly much more intense. I don't know what's going on in this kitchen. I don't know why it's so intense in here. Okay. Ethereal, however you say that one. Now it's a mysterious kitchen. Mysterious kitchen. It's also very loud. How about exciting? This is some very intense coding. What the hell is happening in this kitchen? This time the hell's going on in this kitchen? How about relaxed? That's probably more appropriate. I don't like it. I'm not relaxed. I don't like that audio quality. Suspenseful. Oh no. They say a wash pot never boils, but it's boiling. No, the suspense is you're waiting for it to boil. Is it gonna boil? Is it? I don't know. We'll have to wait to find out. How about upbeat? There's an alien in this water. What the hell's going on in this kitchen? It's an alien, Scully. I believe the truth is out there, or in this pasta water. Upbeat music. Startling. Turn it up, turn it up. What the hell was that? Why is it so loud? What the hell is going on in this kitchen? I think we'll just go with classical. Sheesh. All those other ones are odd. The hell is with this kitchen? Set the audio resource to your desired music and enable loop. Just go with classical. And let's turn that volume way down. That was too loud. Reverb, pitch. Loop it. Make the volume more subtle. Way ahead of you. Keep the spatial blend at the default 2D. So that the background music's presence is consistent throughout the scene, without positional changes. Enter play mode to test. What the hell's going on in this kitchen? We just have some lovely classical music while we cook. Lovely. Still want to turn it down a little. Also, I kind of have to see what happens if I mess with the pitch. Then we'll put it back to 1, but what happens if I change it? Is that gonna make it all chipmunky? I gotta find out. Let's turn the pitch all the way up just to see what happens. It's not relaxing anymore, is it? What horror have I wrought? What happens in the kitchen stays in the kitchen. What fresh horror have I wrought? It's a cat. She's a kitty cat, and she dance, 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 and she dance, dance, dance. Cat. It's a kitty cat, and she dance, 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 and she dance, dance, dance. The horror! The horror! Okay, but now I have to put it all the way to the left and see what happens. What fresh horror will this be? This is rather disorienting. It's rather odd, rather strange. Okay, let's put it back to 1. Sheesh. Okay, it's normal again. But now I have to try messing with the other musics. I gotta do it. I gotta do it. We'll keep the volume lowered, though. Let's keep that volume lower. But let's try the driving music with the pitch all the way up. We gotta see what happens. For the funsies. For the lulz. What horror have I wrought? Kind of a vibe, though, really? It's kind of a vibe. all the way to the left. Just to see what happens for funsies. I don't like that one. What the hell is happening? Ethereal. The slider all the way to the left. Unsettling. And all the way to the right. Kind of a vibe, actually, except it's too fast. I think they lied in its speed along with pitch. I like that. But what if we turned the reverb up? What would it sound like then? What if we turned it from 1 up? What if there's more reverb in it? Then how will it be there? Okay. What if we keep that reverb, but we put the pitch a little bit lower than 1? Just a little bit. I think I'm gonna stick with this actually. I like it. I'm Save it. Okay. Save. Next. Add random bird sounds outside. It is about to be ad time. And no, I'm not paying for viewers. Get the fuck out. Band. Band. Next, we're going to add some ambient bird song. I tried to say sounds and song at the same time. It didn't really work. You'll achieve this effect by positioning audio sources outside the kitchen, such as near a window or in an adjacent outdoor area, and using a custom script to play bird chirping sounds at random intervals. This randomness mimics the natural behavior of birds, making the scene more immersive and lifelike. Create a new audio source and position it where you'd like the sound of a bird to originate. Audio source. Burbs. Burbs. It's burbs. That's descriptive, isn't it? Burbs. Assign the SFX bird 1 sound as the audio resource. Bird. Bird, bird, bird. Bird is the word. Bird, 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 bird. Bird is the word. Bird, bird, bird. Bird is the word. Bird, bird, bird. Bird is the word. Have you heard about the bird? Everybody knows that the bird is the word. Bird, bird, bird. Bird is the word. Sound effects. Bird 1. Whoop. Make sure to set the spatial blend to 1 for full 3D. Whoop. To avoid it playing immediately, disable the play on awake property. Whoop. Select Add Component. Then search for and add a component named Play Sound at random intervals. Whoop. We provided this simple script so that you can play an audio clip at random time intervals. If you want, adjust the properties to change the minimum and to maximum seconds. Enter play mode to hear the bird chirping at random intervals. Have you heard? Have you heard about the bird? I've heard about the bird. It's outside the window. It's outside the window, playing its song at random intervals. You gotta listen for it. Ah! It startled me even though I was expecting it. The birds there. There's a bird. It's the word. Duplicate this audio source for additional birds. Rename each audio source accordingly, and position them at different points around the exterior of the kitchen. For each new bird sound source, choose a different bird chirping sound to vary the soundscape. Enter play mode to appreciate the level of immersion that is added to the scene with this natural sounding ambient audio. Duplicate. Okay, it's not burbs, it's just burb 1. Ooh. Bird 1. Now to duplicate it. Bird 2. Bird 2. Duplicate. Bird 3. Sound effects. Bird 3. Let's move them around. Here's the second one. Okay. Let's appreciate the extra ambiance of the burbs. Think I already saved it, but I'll save it again. Okay, next. Review and proceed. More things to try. Add a humming sound coming from the fridge. Source some new background music. Experiment with reverb zones. I do want to try that one. Let's also try the fridge hum. Add an audio source component to the fridge. But where is the fridge? That. That. Mm. Mm. There's the fridge. It's not a separate object, though. Okay. Audio source, fridge hum. Oh, there we go. In the fridge. It's in the fridge. Fridge hum. There it is. Enable loop. Reduce the volume. Set to full 3D. Let's make the volume super quiet. Make 3D. It's hard to hear it over the music, but I think I can kind of hear it. Da-da-da. Let's make the background music a little bit quieter, actually. Okay. Experiment with reverb zones. A reverb zone in Unity is a spatial audio effect that simulates the way sound reflects and reverberates in a physical space, from echoing caverns to a soundproof padded room. Although it is not entirely necessary to add a reverb zone in this particular scene, it is very cool to see how they work and experiment with different reverb zone presets. I won't do it right now, but it sounds interesting. Proceed. Save. Audio Essentials. Complete the checkpoint. We gotta do the quiz. Quiz time. Quiz time, quiz time. Which of the following statements are true about audio listener components? Submit answers. Leveled up. 600 XP. 2 out of 3 correct. Continue. Next. Programming essentials. Add a movement script. In this first tutorial, you'll add your first lines of C# code to your Unity project to steer your chosen character around the room. Open the new scene. Living room programming scene. Adjust your view. So you gotta go to angle. Add a player to the scene. We have a choice. A robot vacuum sucking up dirt, a toy car getting stars, a wind-up mouse finding cheese, or an alien in a UFO collecting gemstones. It's up to you which one sounds the most fun. Which one should I be? I'm leaning towards the mousy. Finding the cheese. I'll be the mouse finding cheese, I think. Prefabs, characters. Click and drag. The mousy. Eat a mousy. Have it face the center of the room. Rename it player. But it's the mouse. It's a mousy. Ooh. Oh, look at the mousy. Look at the mousy. Rename it player. Create a new player controller script. Unity Essentials scripts. Ignore the provided scripts folder for now. Right-click an empty area, create mono behavior script. Rename it player controller. Whoop. Oh, okay. Enter to save the script name was what I was supposed to do. You'll see the code of the new blank script in the inspector window. Notice that the name of the file is included in the code. That's why it's important to spell the file name correctly. That. Next. Next, you'll apply your script to the player object. Here's a fun fact. In Unity, the scripts you write in C# are components, similar to the rigid body, audio source, and other components you've worked with. The difference between the components you create and Unity's built-in components is that your custom components are editable. I'm going to be ending the stream fairly shortly, but I'll get a bit further first. Click and drag the script onto the character. Save. Unity doesn't allow you to edit code directly in the Unity editor. Well, why not? So the next step is to open your player controller script in a separate script editor application. You may not have realized it at the time, but when you installed Unity, you likely also installed a separate application called Visual Studio, which is a code editing application, also known as an Integrated Development Environment, or IDE. This IDE is where you'll start coding the behavior of your player character. A script editor, such as Visual Studio, provides you with tools and features to write and manage your code efficiently. Double-click the scripts file to open it in your default script editor. Select an app to open this. It's not looking like I have one. Okay, I think I'll have to get back to this because it looks like I don't have the right kind of thing installed to work on this right now. So I'll save this for now. Thank you anyone who stopped by. I think I'm gonna end it there for now. Until next time, it's been fun learning some beginner's Unity. Until next time.